this unit we are going to discuss about two-port RF network circuit representation. The basic objective of this unit is used to learn microwave devices, frequency and characteristics, and formation of S matrix, symmetric and reciprocal networks, and S parameter properties, comparison of S parameter with Z parameter, Y parameter, and ABCD parameter, and basic components of networks, frequency component of resistor, capacitor, inductance, and wires, and various uses of RF and microwave frequencies, various applications of basic components. So first we are going to see about that history of radio frequency and microwave. That is, we know about that Maxwell, that is a famous scientist. In the year 1864 to 1873, he integrated the knowledge of electricity and magnetism by introducing a set of four-quadrant and self-consistent equation which describes the behavior of electricity and magnetic field. This was the beginning of microwave engineering by Maxwell. He predicated the concept of from mathematical standpoint on a theoretical existence of electromagnetic wave propagation, and light was a formation of electromagnetic energy. Both will be the new concept at the time. So in the year 1887 to 1891, a German physics professor, Heinrich Hertz, verified the Maxwell predication experimentally and demonstrated the propagation of electromagnetic waves. Also, he investigated the wave propagation phenomena along the transmission lines and antennas. He could be the first microwave engineer. Next, Lord Ray Wright, he found the possibility of EM wave propagation in waveguides, both circular and rectangular, mathematically, but no experimental work has been done. In the year 1897 to 1936, George Southworth and then Baron experimentally showed that waveguide could be used as a small bandwidth transmission and bandwidth medium, which is capable of carrying high power signals. After the invention of transistors in the year 1950, the invention of microwave integrated circuits in the year 1960, the microwave system on a chip can become a reality. So when we pass the waves through the waveguides, so what will happen means, so the propagation delay that is approximately equal to 0. So then after invention of this microwave integrated circuits, then only it is useful to transmit the live transmission will be possible in real time. Next we are going to discuss about the properties of radio frequency and microwave signals. So properties of radio frequency and microwaves. So it has a great capability to carry the information due to large bandwidth. They travel by line of sight. So there is no line of sight problems. So microwave signals are not bent by the ionosphere. So it has higher antenna gain as the frequency is increased for a given physical antenna. That's why the microwave frequency is the ideal signal band for radar applications. The molecular and atomic nuclear resonance of conductive materials and substances when exposed to microwave fields. So what's the reason to choose that microwave as well as radio frequency? So it has a wider bandwidth due to high frequency, small component size leading to smaller systems, more available and less crowded frequency spectrum, better resolution for radars, low interference due to low signal crowding, high speed of operation, higher antenna gain in smaller space. Disadvantages, so components will be more expensive, low power levels, higher signal losses, use of high speed semiconductors along with their corresponding less massive technology. So what are the applications of microwave? So microwave can be used in communication field. What are the in communication we are going to use that satellite as well as long distance telephone, cellular telephone, and then aircraft, vehicle, personal as well as wireless local area network. There are two important subcategories. One is television and video engineering, radio broadcast, and optical communication. So in television and radio broadcast, in this application, microwave are used as a carrier signal for audio as well as video signal. For example, direct broadcast system, it is used to link the satellites directly to home users. So now and all we can see in our home that is DTH is available. That can be possible with the help of this current microwave technology. Next, optical communication. In this application, a microwave modulator is used in the transmitting side of a low loss optical fiber with a microwave demodulator at the other end. This will act as a modulating signal with the optical signal as a carrier, where a much larger number of frequency channels and less interference from outside electromagnetic radiations are required. This optical communication is very useful. Current applications include telephone cables, computer network links, low noise transmission lines, etc. Navigation. So it is used for orientation and guidance of aircraft, ships and land vehicles, particularly applications such as microwave landing system used to guide the aircraft to land safety at airports. So normally in airport and all, so that aircraft has to find that point where it has to land, so that it can be identified with the help of that microwave landing system. Then global positioning system, so it is used in our mobile phones, so used to find one exact coordinate on the globe. So using the GPS we can able to locate so current location, so where the source as well as destination, so where we are traveling. So in our overall mobile application smartphone we are going to use this GPS. Next, remote sensing. Many satellites are used to monitor the globe constantly for weather conditions, ozone, soil moisture, agriculture, crop protection from forest, snow thickness, icebergs, and monitoring and exploration of natural resources. Next, domestic and industrial applications. It includes the microwave ovens, microwave cloth dryers, fluid heating, moisture sensors, tank gauges, automatic door openers, automatic toll collection, highway traffic monitoring and chip defect detection, flow meters, power transmission in space, food preservation, pest control. Normally that is in our home model we are going to use that microwave oven for our food preparation. So that can be done with the help of that domestic purpose, and for industrial applications, so we are going to use that highway traffic monitoring and control, and then chip defect detection, power transmission in space. So for that industrial application we are going to use this part. Then medical application, it includes that selective heating, heart stimulation, sterilization and imaging. So in order to selectively we have to cut that particular organs, means we are going to use that microwave part to cut that particular part in our body. So for the purpose we are going to use this medical applications. Surveillance, it includes the security system, introduce the detection and then electronic welfare receiver to monitor the signal traffic. And wireless application, short distance communication as well as between the buildings in a local area network can be accomplished by using the radios and then microwave. So these are the categories of applications where that microwave can be used. In astronomy and space exploration, communication, in that optical communication, telephone system, computer network, low noise transmission, TV and radio, direct broadcast satellite, high definition TV. Then in domestic and industrial application, agriculture, moisture detection and soil treatment, pesticides, crop protection, automobiles, and anti-theft, radar or sensor, automatic telecommunication, blind spot radar, collision avoidance radar, near obstacle detection, radar speed sensor, road vehicle communication, and vehicle to vehicle communication, in highways, that is in automatic toll collection, highway traffic and control, range and speed detection, structure inspection, vehicle detection. In microwave heating, that is home microwave ovens, microwave cloth dryer, industrial heating and microwave imaging, so hidden weapon detection, obstacle detection and navigation. So these are the many applications so we are going to see here in this part that can be used. In radar, that can be used as air defense, navigation, airport traffic control, GPS, microwave landing system, police patrol, smart weapons, tracking, weather forecast. In remote sensing, earth monitoring, metallurgy, pollution control, natural resources and exploration. In surveillance, security system, introduce detection, security system, signal traffic monitoring. So microwave band, there are various frequency band consisting of three main commercial frequency band. One is ultra frequency, then another one that is an extra high frequency, and then super high frequency can be further divided into very low frequency, low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extra high frequency. That's a range from 3 to 30 kilohertz to 30 to 300 gigahertz. These are the classification. And then different bands we have: L band, S band, C band, X band, KU band, K band, KA band, Q band, U band, V band, E band, F band, D band, and G band. The length of the circuit, that is L, is much smaller than the wavelength, that is L should be less than the lambda, and then propagation delay time, that is approximate, that is equal to 0, that is in microwave. So this is this part. In this part only we are going to discuss majorly in microwave. So when the propagation delay is approximately equal to 0, so live transmission can be possible. This is the design process of the RF radio frequency design process. So in this it consists of 3 steps. One is DC design process, design consultation, device consultation, and then circuit matching concept. The circuit matching concept majorly depends upon the stability consideration, gain consideration, and noise consideration. In two-port RF network can be classified as a one-port, two-port, or three-port or n-port network. A majority of circuit can be analyzed with the two-port networks. So for low frequency parameters, so in order to characterize the linear network at low frequency, different set of parameters are available. Each and every parameter have its own applications. Voltage and current at each port will provide 4 variables known as V1, V2, I1 and I2. This is V1, this is V2. Input voltage, output voltage. Then I1 and I2. So this is I1, incoming current, and then outgoing current. There are 6 ways of picking a 2 out of a set of 4 variables, but only 4 combinations will give a unique parameter. That is called as an Z parameters, impedance, admittance, hybrid, and then ABCD parameter. Impedance, that is called as a Z, admittance, that is called as a Y, hybrid, that is called as a H, ABCD is parameters. So Z parameters, so that can be for a two-port analysis. So we will get an answer that is a V is equal to V1 by V2, I is equal to I1, I2, Z is equal to Z11, Z12, Z21, and then Z22. In admittance, so we have that is Y parameter, that is in terms of I1, that is equal to Y11 into V1 plus Y12 into V2, I2 that is equal to Y21 into V1 plus Y22 into V2. So finally we have that answer, that is admittance Y is equal to Y11, Y11, Y12, Y21, Y22. And H parameters, so we have a parameters, 2 things, that is V1 and then I2. V1 that is equal to H11 into I1 plus H12 into V2. I2 that is equal to H21 into I1 plus H22 into V2. So we have V1, it is in terms of H11 I1 plus I2 plus H12 into V2, I2 that is equal to H21 into I1 plus H22 into V2. So we have H is equal to H11, H12, H21 and H22. Then transmission ABCD parameter, V1 that is equal to A into V2 minus B into I2, I1 that is equal to C into V2, D into I2. So with that we can able to analyze that low frequency parameters with the help of this Z, Y, H and ABCD parameters.